Hello everyone, it's my honor to speak here, and I'm very glad to share our paper, Dream Experiment, a ISMAR user interface with natural multi-channel interaction for visual experiments with you today. My name is Tianyin Luo, and I come from Hangzhou Normal University. The real experiments have many limitations such as danger, pollution, high cost, abstract, and invisible. ISMAR provides users with a natural interface that can solve the limitations of the real experiments. However, traditional ISMAR experimental environments also have some limitations. Lack of robust 3D registration, virtual real occlusion, realistic interactive methods. This paper studies a set of ISMAR technologies for middle school experimental environments and developed an ISMAR user interface called Dream Experiment. The contributions of this paper are shown on this page. We use an experimental interaction scene to introduce the Dream Experiment. We use one RGBD camera as the main camera and two RGB cameras as the auxiliary cameras. The final image rendered by ISMAR is displayed by PC screen in real time. In addition, we also design sensors which generate odors and temperature. Tangible interaction with 6-stop has real sense of operation, attaching markers to the tangible devices and then performing 6-stop pose estimation is a method with high real-time accuracy and robustness. However, some devices are too thin to attach the markers. Some devices are large, heavy, or expensive. For these devices, we use virtual objects or replacement tangible objects. We study a multi-camera cooperative 3D registration algorithm to create a robust 6-stop interactive space, especially to solve the delta problem of registered virtual objects caused by inconsistent pose estimation when multiple cameras track the same mark in the same frame. We set a confidence level for each camera to do registration for a marker. The confidence level is calculated based on the distance and angle between the camera and the marker, and the ratio of marker pixels to the image. For details of the algorithm, please see our paper. This is the result of multi-camera algorithm. Affected by noise, the accuracy of the original depth information obtained by the depth camera is poor, especially translucent objects. But in ISMAR experiments, the foreground objects are multi-layer and have tangible translucent devices. In order to correct the depth map of multi-layer objects, the accurate pixel array of each foreground object is segmented through deep learning method. Then we correct the depth map of real scene by the pixel mask of each object, and the depth map of the 3D registered translucent devices. Finally, we render the occlusion relationship by comparing the virtual and real depth maps pixel by pixel. Segmentation uses a lightweight convolutional neural network called CBAM-UNet, which combines the convolutional block attention module with UNet. For details of the algorithm for correct and rendering, please see our paper. These are the results of our virtual real occlusion method. We designed multimodal interaction methods for the experimental user interface, include tangible interaction, gesture interaction with touching, voice interaction to generate virtual devices, temperature and smell interaction. This is a demo for 3 experiments in Dream Experiment.
Tube
tube, cotton, catheter, sink, match, gas cylinder, match, We set up for ablation experimental environments and for tasks to compare the effect of dream experiment with the traditional MR environments. After the ANOVA and post-hoc comparison test, the result shows the time performance is no significant difference from the real experimental environment, and better than the traditional MR experimental environment. The results of questionnaires shows dream experiment is better than traditional MR experiment environments in user experience, and better than real experiments in some respects.